there's got to be a series of advantages all the way in the feather. If you can't think of one, then that's your problem, not natural selection's problem. Natural selection, well, I suppose that is a sort of matter of faith on my part, since the theory is so coherent and so powerful.
Nate here is going to be talking about an upcoming book, actually, that he has coming out that's going to go against, right, many of these ideas that not only Biologos promotes, but also atheistic evolutionists promote. And so he's going to be talking about that with us today.
So this is called Answers News, and I thought today we could make some news.
Okay.
It's sad that we have a gentleman who wrote a book 150 years ago whose birthday we celebrate in a field that is constantly changing.
Very true.
So here we're celebrating a landmark supposed discovery, but one of the points of this book I'll be making, hopefully making news, is the origin of species, his question, is not something that is really set in stone. It's inevitable that the answers will be totally rewritten every so often. So one of the points I'll be making in the opening chapter of my book is...
And what is the book entitled?
So the book is titled Replacing Darwin.
Okay.
So for many years we've tried to rebut Darwin. I think science has advanced to such a state we're not just rebutting him, we're totally replacing him. So how's that for making news?
So a book written in 1859 is going to be totally replaced, right, with something new now.
And subtitling it, The New Origin of Species.
Okay.
Because I think we now have data, not just to say here's where the holes are. That's almost irrelevant now.
Right.
That it's really the creationists who've now come up with a testable, predictive model to explain where species came from. So, of course, this is a shocking, revolutionary claim.
Yeah.
It's less shocking, I think, if you understand the history of the debate. So, it's a recent debate in the history of life, really.
Yeah. Last few hundred years.
You have Greeks and others who've studied life. I mean, anyone who's been outside, studies life, looks at it, thinks it's interesting. But in a formal, systematic way, pretty much every creationist evolutionist would say this goes back to Linnaeus.
Okay.
We haven't had genus, species, names that are universally used, and you really can't have a debate if we can't agree on the terms. So now Linnaeus, the 10th edition of his work classifying life was 1758 or so. So until 2017 now, less than 300 years. That's when we have species to debate and to discuss their origins. And one analogy I like to use to help people understand what exactly we're doing is as I think of a gigantic jigsaw puzzle. I've done them, probably many people have done these, and you have varying levels of challenge and difficulty. You can get a 1,000-piece one, but in every case, if you're like me, it helps to have the box covered to know what the final image is supposed to be. I have corner pieces, I look for those first if I can find them, or the edge pieces at least, because this helps set the framework, it constrains the size, it gives me a sense for how the pieces will eventually fit together.
Okay.
And I work on the easy stuff first. Well, the origin of species is like a puzzle. Species are pieces of the puzzle. Those first pieces were discovered, Linnaeus, really, you could say. And the clues to their origin are pieces of the puzzle as well. So you can think, well, if everything is connected, if all these species are connected, we could say it looks like life is totally related. That was Darwin's point.
Right.
Or if you're in Linnaeus's day, let's think about mammals as an example. We're classified as mammals, but primates, so forth, elephants, mammals. He listed less than 200 mammal species. So you have a few scattered species. They may not look terribly connected to one another. You might say, hey, if I go to the Arctic, I can find a polar bear, an Arctic fox, and Arctic hare. They blend in very well. I don't know of too many other species. Or maybe you'll go south, then you'll find a black bear in North America, maybe a jackrabbit, a red fox in Eurasia. Everywhere you go, you find some sort of signature species. They fit their environment. Obviously, the white coats of the polar bear help it blend in. Black bear blends in better with its dark coat in the forest in which it roams. Few pieces, they seem to fit in the environment which they live. It's as if they were designed for that environment.
Right.
It doesn't look like they're connected. It's as if they were made to exist there and have always existed there and never anywhere else.
Right. So the idea of species fixity,
Exactly.
basically. Okay.
So Darwin's 100 years after that, 1859. He comes along. There's more species by then.
Right.
Now there's closer to 1,800 mammal species, so he's got more pieces to work with. He's got more clues to work with. He's going to invoke the fossil record, global geography. You think of just a basic history. How much of the world do we know?
Right. Yeah.
You can look at Linnaeus's list and even get a sense for exploration, what was missing from his list, mammal-wise. A whole lot of marsupials.
Oh,
So,
yeah, right.
Who went to Australia by
Right.
1758 and reported
To
on what
study
they
the
found there?
animals, yeah.
So Darwin has some marsupials at his disposal, but let's just continue this history and not stop it there. 2017, there's over 5,400 mammal species.
Wow.
And you can make some rough estimates, not just of mammals, but all of life. Insects, bugs, spiders, arthropods, you name it. Crustaceans. We now have 1.6 documented species, 1.6 million documented species. Plants, animals, bacteria, so forth.
Yeah.
Less than half of those were documented in Darwin's day.
Right.
So he's
and
working
there's still
with
many more.
And
I mean,
we've-
even
yes.
bacteria alone may account for millions of more species.
So a conservative estimate would say maybe 10 million. You can kind of chart how species have been discovered and number of genera, number of
Right.
families, and some of them are starting to tail off. Some of them continue
Sure.
upwards.
Right.
So some of the estimates I've seen say maybe 10 million. So let's say this jigsaw puzzle is 10 million pieces in size, and again, clues are pieces. So let's say 10 clues conservatively per species. You're talking about a puzzle that's 100 million pieces in size. Massive puzzle.
That's big.
And so you got from Linnaeus, who's got a handful. He's going to arrange the puzzle a certain way. Darwin's going to come along with more pieces and going to rearrange the puzzle. It's inevitable that as you get more pieces and it's this massive puzzle, it's going to be totally rearranged. And unlike a typical jigsaw puzzle, there's no box cover. We have the scriptures to guide us, but the scripture doesn't mention the elephant species. It's a clue. But it shouldn't be any surprise that I'm going to sit here and say we can replace Darwin, totally rewrite this puzzle.
So you're basically saying that the way that we arrange the pieces has a lot to do with our starting points and our worldview for understanding the past and how these organisms all came to be. So it's because we don't, essentially, they don't have, I mean, we do have the picture on the front of the box to a degree because we know that God created animals according to their kind, but we still have to figure out how all of these different species came about from those original kinds.
Yes, that's true. And I'd say there's 2 points to be made there. One is all of us today, we're still working with a highly incomplete puzzle.
Right.
That maybe 80%, 85% of species have yet to be discovered, and we think we have the final answer. So all of us are going to have a framework, at least in our head, some sort of cover or image through which we interpret and say, I think
Right.
there's going to be a missing piece right there. And it's going to look like this shape, and that's a way to evaluate the usefulness of your puzzle. Is it making accurate predictions? And so we that's one of the things that's happened since Darwin. We're able to make predictions now that are accurate, that explain where they came from. One of the other things that's a major absence from Darwin's puzzle, so not only is the number of species, the number of clues massively increased, just as it massively increased from Linnaeus to Darwin, we now have the edge pieces. Darwin had no edge pieces to his puzzle. Well, what are edge pieces? We know in jigsaw puzzle terms exactly what they do. They constrain, they put boundaries in the puzzle.
Right, they frame it.
If all species were related, you might still discover edge pieces, but it really forms just one edge here, maybe just one big frame. Whereas if they're distinct, you're going to find orders of magnitude more.
Right.
This particular group of species is boxed in, and this particular, and this group, they're all separate and distinct. Well, what are the edge pieces, biologically speaking, because we're dealing with animals, not
Right.
puzzle pieces? What constrains our question? What constrains our answers? Well, you think about what defines species. There's a lot of definitions. That's part of the problem.
Oh, yeah. And depending on what organism you're even
Exactly.
talking about, it
Exactly.
changes.
One of the things that they all have in common is we define species by their traits, basically. We intuitively recognize it. The elephant by its trunk, and the Asian elephant is different from the African elephant because of the shape of the ears and,
Right.
and the back and so forth. The camel by its hump, or the number of its humps, and the llama by its, and so forth. Butterfly by its wings, and the pattern on its wings. So all these different traits in these millions of species around the globe define them. Whether we need a microscope or not, that's still the definition of a species, by and large. So now I'll just work that definition backwards. If you want to understand the origin of species, you've got to understand the origin of traits. If you want to know the origin of the elephant species, you've got to know the origin of elephant trunks. You've got to explain that. Those traits, or at least the information we'd say encoding those traits,
Right.
is inherited consistently from generation to generation.
Right. Elephants always give elephants.
And in fact, if that weren't true, we wouldn't even be having this discussion.
Right.
If an elephant could birth a giraffe, which could birth a snake, which could birth a bacteria,
We can't, yeah.
there would be no term in our vocabulary.
There's no consistency.
So the fact that these can produce a consistent form that we
Right.
recognize as a species means then that this is getting towards genetics. So these traits that define species are inherited consistently every generation, and what controls that inheritance is genetics. That is the only direct scientific record of a species' origin.
So not the fossil record.
Fossils are not inherited, geography is not inherited, geology is not inherited. Something else is. And I say something else because we're going to try to dial the clock back to 1859 and say, what did Darwin know in this most important of fields? And he tells us in, I think it's chapter 5, in the summary section on the origin of species, he says, our ignorance of the laws of variation is profound. Why doesn't he say genetics? Because the term isn't even invented.
I was going to say, he doesn't know what genetics is.
The term wasn't invented until the turn of the century.
Right.
Now, if you wanted to understand the origin of traits, let's say the elephant, you might start with, well, let's see what we can do with our own species. We have family trees. Darwin had a family tree. You can look at your own family tree and say, well, maybe this comes from dad, this nose shape comes from mom, and you try to go backwards. Well, my family tree runs out pretty fast, and I'm going to guess most of the people's do too. So you might say, well, let's bring in a few other family trees and expand our looking at traits. Maybe red hair and freckles, we'll trace that. But if you do this, again, you see all sorts of odd and weird things. Red hair might be present in grandma and then disappear and not been into the children or grandchildren.
Right.
It might show up randomly here. So if all you have is a family tree, you're going to run into a whole bunch of paradoxes that you're not going to be able to explain. And that's all Darwin had in 1859 is paradoxes.
Right.
Something is similar. Humans produce humans. That's descent. Something changes. Modification. Descent with modification was his phrase.
And you just give it enough time and, molecules can go to man.
That puts no constraints on our understanding. The genetic differences among species, that's the direct constraint and the boundary of these answers. So Darwin himself said we didn't know what genetics was. If you open a modern genetics textbook, it starts with Gregor Mendel. Gregor Mendel published 1866, which is 6 years after Darwin publishes 1859, The Origin of Species. And Mendel is really just doing family tree analysis of pea plants because no one had done it rigorously and quantitatively. The work was lost for several decades. Around the turn of the century, his concepts are connected to chromosomes. So cytologists are now studying cells with the microscope and saying, oh, these things behave like what Mendel discovered.
Right, microscopic gets better.
And then genetics is coined as a field. Well, chromosomes, digging down even deeper, are made of both DNA and protein.
Right.
That sets off a debate of several decades.
Which is it? That's actually the inheritable factor. What is the
yes,
is it DNA or
exactly.
is it proteins?
And many people thought proteins because if you do the math, they have theoretically more information
variety.
Storage capacity.
Yeah.
And it took a long time, really not until the structure of DNA was discovered in 1953 to finally say for the community to say it's DNA.
Right.
It's not proteins. So 1953, 1859, nearly 100 years from when Darwin writes his book till we finally can say it's DNA.
Right.
That's the substance of heredity. And again, that's just the beginning of a whole other series of discoveries, which is, well, what is the DNA sequence then among the various creatures?
Right.
Our own sequence, we're the best genetically studied species on the planet. Our own sequence isn't until 2001. So all that to say, Darwin took a gigantic risk when he wrote The Origin of Species. Genetics, the origin of species is a question of the origin of traits. Traits are encoded by genetics. Darwin had no genetic knowledge in his day. And it really hasn't been until now that we've had genetic sequences to put boundaries on this puzzle and say, this is what you have to explain. These are the direct differences you have to account for. These are the ones you have to quantify and explain their origin. So it's inevitable that we're going to reevaluate this puzzle.
Right. Once our knowledge has increased now, we can explain this.
Not only has the number of species increased, but all these essential edge pieces have finally come into view, finally been discovered. And we can finally say, well, are there just a few that kind of go around the entire globe of species, or are there a whole bunch that mark off this, and this, and this, and this? So this is a huge element of this debate that really has not been discussed at all. Of course, if you admit that, oh, well, we've been arguing about indirect data for 150 years, now you've just sort of given away the house. And oftentimes what people will say is, well, if what you're saying is true, how in the world could you make this point in the first place? You open up a textbook, this evolution textbook I have in front of me, pages and pages, hundreds of pages supposedly of evidence for evolution. How can they say that if they didn't have genetic evidence for 150 years? Well, the answer is science can work indirectly through a very specific method with very specific rules that Darwin tried to follow. But just like the scientific knowledge of the community was dated, so was his opposition. It was basically the idea of Linnaeus, that, we have a few species here, they fit their environment, species fixity. He was able to easily refute that.
Right.
What he didn't refute was this general idea of design, and what the biblical view,
right,
that God creates kinds, which is probably more the level of not species or genus, but family,
right,
that Noah takes to every kind on board the ark. And so there's some limited speciation that can happen. So you take your classic textbook examples. Homology, the fact that the structure of our forelimb is similar to that of a dog and to a whale and to a bird. What do humans design? Look at the vehicles we design. They all have headlights in the front and doors on the side and wheels on the bottom. Why? Because it's easier to go in through the side instead of jumping through the top. There are design constraints, basically, that work better in one scenario than another. So Darwin was able to refute the idea of species fixity by saying, well, here's this pattern that's shared. The only explanation he could think of was common ancestry. Well, fast forward 150 years, we are able to think and observe what humans design betterly, globally. And across the globe, we use similar design principles, similar underlying anatomy in vehicles. Why is an Asian automaker and a German automaker and a U.S. automaker all using the same basic body plan for that car? Because that's what works. It fulfills the purpose. Even the idea of transitional forms. That refutes the idea of species fixity, but it doesn't refute the idea that God designed transitional forms, if I can call it that. Transitional forms, those that blend the features of two very different species. So, take Tiktaalik, the fishapod, supposedly blends the features of fish and amphibians. Well, if humans want to design something for the ocean, they design a ship. For the land, think of military, they design a tank. If you want to move between those two environments, you design an amphibious assault vehicle that blends the features of those two very different vehicles. So even transitional forms, homology, all of these fail to reject the design hypothesis.
But in fact, there are things that we would think about, just like you were given those examples, just from our design perspective of how we design and how we do things. And obviously, we're made in the image of God, so it's not surprising that we would do things similar to how he does them.
Exactly. And I think of this in puzzle analogy. Let's say you're Darwin. You have no edge pieces. You have no box cover. You have no idea what the final number of pieces is. And today we'd say there's probably 100 million. And he had less than half of species and no genetic data. What are you going to do? What if you're doing a real jigsaw puzzle? What would you do? If I was doing that, I'd probably just start looking for pieces that look kind of similar, try to connect them. Some of them might look like they work.
Right.
If you've got this massive puzzle, inevitably there's going to be some, and all you have is 50,000 pieces, let's say, of this 100 million piece puzzle. Something's going to look like it kind of fits, and I'm going to go with it, and I'm going to try this one. If that fits, I'm just going to keep going with it. And so really that's what the homology evidence is, transitional forms, these sorts of things. They seem to fit in his mind. But as we're saying too, there's a whole framework where you can make predictions and test things. I can easily take those same pieces and say, no, they're disconnected. They connect to these separate puzzles over here just fine. And so, 1859 till now, there's a revolution in biology because now we have the edge pieces, and now we're able to unlock some of these false connections that he made and put them in their correct places. Or at a minimum say, you can't unambiguously put these two together.
Right. There could be another way that they fit in the puzzle.
This fits, and now that we got all these other pieces, it fits here, and maybe here, and here.
And it fits better.
And it fits better. Especially when you have these edge pieces that constrain it. So this is a huge discovery, really, that many people don't realize, and why one of the reasons we can replace Darwin. We have these edge pieces now where we can set the boundaries of the puzzle. We've unlocked some of these center pieces. We rearranged the center, which we can do again because we have more pieces now, and it's something we shouldn't be surprised at. In 50 years, when we have maybe 10 million species, we might rearrange it some more.
Yeah. But the basic model is still the same, though. We're not changing. We're not saying one kind of organism goes to another because we know that's part of the constraints that can't happen.
Yes.
But we're trying to understand just how these different species have come from those original kinds.
Yes. And one of the exciting biggest developments, I would say, is, to go back to the puzzle analogy, is the discovery of corner pieces. So you have edges that set the boundaries that say the puzzle goes this far, or it's got to line up in this way, or along this edge. The corners now connect these edges and put real hard constraints and orient the edges and orient the puzzle. And some of the discoveries that have been made recently in genetics just in the last few years being able to predict mutation rates. Some of the research I've done, where you, and I was surprised to find this, basically, you look at one section of DNA, mitochondrial DNA, in a variety of species. We only have a handful again, because this is a recent field.
Right.
We've just barely scratched the surface in getting genetic sequences. Even less is known than about the rate of mutation in these various species. But in those few that we have, it fits exactly what you'd expect, starting 6,000 years ago, mutating at a constant rate. Again, why would you expect constant rate?
Because that's what evolutionists always expect.
Yeah, they expect that, and it happens to predict exactly what we see. And it's so strong that I think I can predict then the mutation rate for all these other species on the planet, which is yet to be measured.
Right, and that's what's amazing about some of Nate's research that he's published in like Answers Research Journal. It's just amazing to see how it fits so well with the biblical timeline and what we would expect. But if you look at it compared to the evolutionary timeline and the mutation rate, there should be, if it's really as old as they say it is, you should have a ton of mutations. It should be, and you don't see that. You don't observe that. It's not what's there.
So let's think about the significance of this in three respects. First of all, in the wider history of this debate, you've got people, I have Fukuyama's textbook here, Evolution. He's got a whole chapter on creation, evolutionary science, creationism and society. This is the third edition, 2013, I think. So what does he say about creation? Of course, he says it's not science, of course. Science is not a collection of facts. It's rather a process of acquiring an understanding of natural phenomena. And he has italicized here, the most important feature of scientific hypotheses is that they are testable, at least in principle. And evolutionists have said for many years, evolution is testable. We can make predictions and confirm them in the field. So I'm now making predictions about mutation rates in the field by the evolutionist's own standard.
Right.
This should be accepted as a full-fledged scientific model. So we've now, I would say, basically beat them at their own game, so to speak. I wouldn't necessarily call it a game, because this is how science works.
It's scientific research.
And it's advancing our understanding of the world. If I can predict the rate at which things change, this is something people should be excited about. So that's the second point. I'm not predicting the size of the elephant trunk, per se, or some obscure phenomenon. I'm saying I can predict the rate at which the engine of evolution is supposed to operate. This is the central mechanistic component of what evolutionists say. It's the young earth creationists who are able to make a prediction and say,
you've got to have
right there.
some sort of generation of the raw material or the raw information to go from one kind of organism to another.
And then the third way in which this is so revolutionary, and you alluded to this, is evolutionists in geology and paleontology and these other fields, astronomy, by and large assume that the rates we see today in the present, that we can measure, the rate of erosion in the Grand Canyon, is something we should extrapolate backwards without much modification of the past. So the entire edifice of millions of years that Darwin assumed, because Lyell preceded him, and he just adopted it for his model, that whole time scale rests on this assumption of constant rates of change. Well, we take that same assumption, apply it to genetics now, the most important scientific field on the origin of species, and it gives the opposite of what Darwin said.
Right.
So this meets the evolutionist's own test. It's on the most important question, the most important field in this debate, on the central mechanism of evolution, and completely reverses throws into confusion the entire edifice of their time scale. This is a really strong, this is why I say this, we're replacing Darwin.
Right.
We're taking what he's done, we've shown some, not just some of the errors, but we're saying all those standards they've set up, all of those planks they've put in place, that we've now flipped basically, and said, here's the strong new standard that everyone else needs to meet. If someone has a better idea, what testable predictions did it make? Now we can be in the evolutionist's shoes and say, you've got something to contradict what I've just said? Well, what testable predictions does that make? Don't just find holes in what I've just told you.
Right.
Because this is a very successful scientific model. Show us something better. Right. Show us how evolution advances understanding of science. Predict for me the mutation rate, the most important element of your model. Tell us exactly now with these new constraints, these edge pieces. Show us how they're supposed to be oriented. Connect these in a way that makes sense of what we see. So,
because that mutation rate has to be fast enough to generate the, huge volume of mutations that you're going to have to change one kind of organism to another. And like with your work, what you've shown is it just doesn't exist. It's not there. You're not making that many changes. You don't see those many changes in organisms.
And it's a double-edged sword. You have to get enough to produce the change in the right order, in the right way, in the right combination. But you can't have too many.
Yeah.
Which is, for some DNA compartments, it looks like the current rates of mutation are so fast, it would just destroy the organism.
Right.
They might invoke natural selection, but what I'd say to them then, of course, is, what testable predictions does natural selection make? Sure, it's survival of the fittest, but how does that give me a number that I can say, this is going to be the rate at which this fruit fly changes. This is going to be the rate at which the elephant DNA mutates. This is the rate at which the cheetah DNA mutates. Give me something that works, that's testable, that's predictable.
Yeah.
One other thing people ask, this is really a debate for anyone who's not a scientist, a debate over who you trust.
Well, and that's always the big question, because somebody could say, well, you guys have PhDs, so why should we trust you over these people over here that have PhDs? Maybe in very similar fields, and that's always the big question.
And what intimidates many people is, you look at surveys, and 97% of scientists would disagree with everything I've just told you. This is not a revolution in biology. Evolution is a well-established scientific idea. So how do you explain that?
Right.
And really, that question cuts both ways, because there are, again, the vast majority who agree with evolution, but there's a group of dissenters who are no dummies. I mean, I think of my colleague Jeff Tompkins at the Institute for Creation Research. PhD geneticist, worked in genomics for 10 years, ran the Genomics Institute for 5 years at Clemson, has worked on DNA sequencing or analyzing the genomes of plants, animals, bacteria. I've got a list here.
Right.
Bumblebee, honeybee, oysters, rice, corn, shrubs, trees, so forth. No dummy when it comes to the field of genetics, and is doing creationist research in his own field. It's not like he's jumping into something he knows nothing what he's talking about. So how do you explain that? So that's the dilemma for anyone. Who do you trust? If you trust the 97%, well, why aren't there intelligent dissenters? If you trust the dissenters, why does 97% not agree?
Well, it's just like the Is Genesis History movie. That's one of the things they're trying to show, is that these are very intelligent people who have went to very reputable institutions, but who believe different than the 97%.
What was sort of shocking to me to discover is to find out what the 97% thinks of the dissenters. Obviously disagree. That's without question. But how do they explain the existence of people like me, like Jeff Tompkins? And there was an interview with Randy Isaacs, who is the head of the American Scientific Affiliation, which is, by and large, a group of theistic evolutionists, professing Christians who are professional scientists, but pretty much not young earthers. So what do they think about people like me, like you, like Jeff Tompkins? And the American Scientific Affiliation has a position of not taking a position on controversial issues.
A no position.
So they interviewed Randy Isaac on his retirement, basically, from being, I think, president or executive director here. And they said, so Randy Isaac said this. He said, the oft-stated policy not to take a position in areas of honest disagreement among Christians is an extremely important aspect that characterizes the American Scientific Affiliation, or the ASA. It's the most difficult one to maintain. For one thing, it is not easy to differentiate an honest disagreement from a dishonest one. My personal preference, though not an official ASA position, was that the reference for honest disagreements was the accepted consensus view of the scientific community for scientific matters. So basically, if I, just by virtue of me disagreeing with the consensus, he would say I'm a liar.
Yeah, you're a liar.
And I've seen this from BioLogos. I've seen this from Randy Isaac, who was, I think, on the scientific advisory board for a while. And these are from professing Christians, basically. So surveys also show, the same surveys that show 97% accept evolution, at least 2/3 of professional scientists cannot positively say they believe in God. So for Christians, you're dealing with a group of people here, the scientific community, that is by and large unbelieving. And when you deal with the Christians in that community, they basically say we're liars.
Yeah, and that can explain a lot, though, why they will not engage. We're always talking about that, how frustrated we are that theistic evolutionists and others, atheistic evolutionists, they won't read our stuff. They won't read the papers we publish, look at the research we've done. They won't directly engage with it. It's because they think we're lying. So they don't want to have anything to do with it. They won't even look at it.
And in a sense, this explains all aspects of that question of who do you trust. So if you trust the 97%, this seems to be where you're forced to go. I must be lying. Jeff Tompkins must be lying in the stuff he's publishing. And by saying you're lying if you disagree with the consensus, you also have an immediate explanation for why the 97% would disagree with me.
Right.
What do I make of the fact that 97% don't agree with me? Well, they think just the fact of disagreeing is enough to make me dishonest, and so they don't bother to investigate anything I've done. So, of course, there's this self-reinforcing loop that prevents them from even considering alternative ideas. All these scientists basically go through the public school system. They're not even allowed, practically speaking, to learn about alternative views. So it is a question of who you trust. Hopefully people can see the character of you and me and people like Jeff Tompkins and elsewhere, that we're not out to lie or deliberately manipulate the data. We're saying there is a legitimate, full-fledged alternative, which I'll be laying out in this book, refuting or replacing Darwin, New Origin of Species, and we're not lying. It'll be fully referenced. It'll be out there for people to engage. Really the question is not only who do you trust, but who are you willing to engage with in an honest way and weigh the evidence for yourself.
And it's scientifically sound. That's what I love about this, is it's scientifically sound, but also absolutely consistent with a historical reading of Genesis, with believing that what it says literally. And that's what's so great about this, is we, as creationists and as scientists, we can be sure that, what we believe from the Bible, it's reasonable. It's a reasoned faith. That's what I would say. We would expect the science to be consistent with what we read in the Bible and to confirm that, and it does. And so be looking for that book coming out in the fall, right? And so we'll be talking about replacing Darwin, I'm sure, again. Once the book comes out, we'll have Nate on to talk more about it, and probably hopefully people will engage with it and really be reading what we're saying and why we're saying it and why this is important. So we're going to be signing off.
Well, I suppose that is a sort of matter of faith on my part.